Magora Math Circle, and today I'll be presenting Math Kangaroo 2018 levels 5 and 6. Problem 1. The drawing shows 3 flying arrows and 9 balloons that do not move. When an arrow hits a balloon, the balloon pops, and the arrow flies further in the same direction. How many balloons will not be hit by arrows? A, 3, B, 2, C, 6, D, 5, or E, 4. So they have the arrows drawn out for us, and we just link them through their path, and we see that 1, 2, 3, 4, 5, 6 balloons are eliminated. That leaves 1, 2, 3 balloons left. Therefore, the answer is A, 3 balloons. Now, problem 2. There are 3 objects on the table. What does Peter see if he looks at the table from above? A, B, C, D, or E? For A, we can see that the square is lined up, but the circle is not. Therefore, A cannot be the answer. B, we can see the square is also lined up, but the circle is not lined up either. So, therefore, B is not the answer either. C seems to be the perfect fit, but let us check the other 2 possibilities to see if any of those are also the solution. D, the square is in the wrong place and the circle is in the wrong place. So obviously it cannot be the solution. And E. For E, the square is in the wrong place, but the circle is in the right place. Therefore, it cannot be E either. So the answer is C. Problem 3. Diana first got 14 points with 2 arrows on the target. The second time, she got 16 points. How many points did she get the third time? Well, we see over here that we have a 14 and the 2 arrows are in the same area. So we know that 14 equals 7 plus 7. Therefore, we know this area is 7. We go over here and we label this as 7. And then now we have 16 minus 7 equals 9. So now we know that this middle part is 9. We move on to this last one where we're trying to solve the values. And we see that both arrows are in the 9 sector. Therefore, we do 9 plus 9, which equals 18. Therefore, the answer is B, 18. Problem 4. A garden is divided into identical 1 meter by 1 meter squares. A fast snail and a slow snail move along the perimeter of the garden, starting from corner S, but in different directions. The slow snail moves at a speed of 1 meter per hour, and the fast one moves at 2 meters per hour. At what point will the 2 snails meet? So point P is marked over here, or point S. So we know that they both start here, and they both go their separate ways. So let's say it says that the slow one goes this way and the fast one goes this way. The slow one would go 1 per hour. So you'd go 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. The fast one, on the other hand, goes 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. And we just continue this. 1, 1, 2. So now we've gone 1, 2, 3, 4, 5, 6, 7, 8 times for the slow one. 1, 2, 3, 4, 5, 6, 7 times. So then we go once more, and we see that we meet at point B. So, therefore, the answer is B. B. Problem 5. Alice subtracted 2-digit numbers to 2-digit numbers. Then she painted 2 cells. What is the sum of the 2 digits in the painted cells? Well, we have blank 3 minus 2 blank equals 25. So if we put this in a different way, we have blank 3 minus 2 blank. But we can't get 5 out of 3. So therefore we would need to borrow something, 1 from here, which means that this number would have to be 8 and this number would have to be 5. And if we plug those in, we have 53 minus 28. And then we get 25 out of this because we get 4, we borrow, this becomes 13, we subtract 13, you get 5, and then you have 4 minus 2, which equals 2, and then you have 25. So the sum of the two numbers here is 4 and 5 and 8. We add 5 plus 8, and we get 13. Therefore, the answer is D, 13. D, 13. Problem 6. A star is made of 4 equilateral triangles and a square. The perimeter of the square is 36 centimeters. What is the perimeter of the star? We know that the perimeter of the square is 36 centimeters. We know that a square has 4 sides. 36 divided by 4 would equal 9. We have 9, and we know that these are all equilateral triangles. Therefore, each of these sides is 9. So we have 1, 2, 3, 4, 5, 6, 7, 8. 8 times 9, which happens to be 72. So the answer is E, 72. Problem 7. The picture shows the calendar of a certain month. Unfortunately, an ink spot covers most of the dates. What date is the 25th of that month? So we can see that the first Thursday and Friday are not covered. So we can just add 7 to this Friday and we can get the 25, which is covered. So 3 plus 7 equals 10. 10 plus 7 equals 17. 17 plus 7 equals 24. And once we get 24, we see 24 is really close to 25. We just need to count one day over. So 25 would be Saturday. And that the answer would be D, Saturday. Problem 8. How many times do we have to roll a regular die to be sure that at least one result will be repeated? Well, a die is 6-sided, and we know that we're looking for probability, and we're seeing what is the least possible rolls we have to do to get at least one repeated. But the thing is, what happens if you roll it 6 times and you get a different number every single time? Then you need to roll it a 7th time. So, in order to make sure that you actually have a double, you need to roll it 7 times. So the answer is C, 7. There are 3 squares in the problem 9. There are 3 squares in the figure. The side length of the smallest square is 6 centimeters. What is the side length of the largest square? Well, we can see that there's a 2 centimeter difference. This is 2 centimeters and this is 2 centimeters. We know this is 6, so 6 minus 2 would equal 4. We know this is 4. And then 6 plus 2 would equal 8. And we know that is 8, which means this is also 8. So 8 plus 4 equals 6 equals 12. So therefore the answer is C, 12. Problem 10. In the figure on the right, the circles are light bulbs connected to some other light bulbs. Initially, all the light bulbs are off. When you touch a light bulb, this light bulb and its neighbors are lit. At least how many light bulbs do you have to touch to light all the light bulbs? A, 2, B, 3, C, 4, D, 5, or E, 6. So, if we look at this, we have to find the light bulb with the most neighbors. We look at this light bulb. This light bulb only has 2 neighbors. Not good. This light bulb has 1, 2, 3 neighbors. So, if we tap on this light bulb, it sets off these. So we know now that 4 of these are on. This whole section is on. So then we have to find a light bulb here to tap. So we look at this one. This one you can only light 2. Not enough. We want to light all 4 of these. We tap this one. Only lights 2. tap this one, only lights 1. And it also turns, so we must tap this one because this one also has 3 and it'll turn on all these. Therefore, you need to tap at least 2 times. The answer is A, 2. Problem 11. In which of the 4 squares is the ratio of the black area to the white area the largest? A, B, B, C, C, D, D, E, they are all the same. So we look at A and we see that this square is split up into 8 pieces. Out of these 8 pieces, 2 of the 8 pieces are taken by black. So we move on. We look at this one, same thing, broken up into 8 pieces. Out of these 8 pieces, 2 are also black, 2 over 8. So far, these 2 are the same. For this, it's broken up into 16 pieces. So we have 4 over 16, which also could translate to 2 over 8. And for D, it's the exact same thing. 4 over 16, or 2 over 8. So we can see that these are all the same, therefore E is the answer. They are all the same. Problem 12. 9 cars arrive at an intersection and drive off as indicated by the arrows. Which figure shows these cars after they leave the intersection? Well, first we know that there are 1, 2, 3, 4, 5, 6, 7, 8, 9 cars, and we have to trace where they go. Let's see how many go here first. So that's 1, 2, 3, and 4. So 4 go here. And we can already see that 3 of these don't include 4 on that side. So now we're down to 2. So we have 2 left, and the main difference is this, the top. So let us solve for the top. We see that if we look closely, only this one, is going to the top. Therefore, the answer is B. Problem 13. 4 of the 5 numbers, 1, 2, 3, 4, and 5, were used so that both calculations following the arrows are correct. The numbers are not shown. Which number is covered with the spot on the star? So we have to get 8 in the end. So we kind of assume that this has to be 4 because 4 times 2 would equal 8. And if we insert 2 into here, the only way we could have that equal to 8 is if we had it divisible by 1. Now, then we have to look at this. 4 is here, star is here, and then you minus 1 from 4 plus star. So 4 plus 5 would minus 1 would equal 8. Therefore, the number under the star is 5, or E. Problem 14. A line is behind one of the 3 doors. A sentence is written on each door, but only one of the sentences is true. Behind which door is the line? A, door 1. B, door 2. C, door 3. D, all 3 doors are possible. Or E, both door 1 and door 2 are possible. So we look at these 3 sentences. The line is not behind this door. We can't be sure about that. The line is behind this door. We can't be sure about that. The sum of 2 and 3 is 5. We know that is, for a fact, true. So we mark this one as the true sentence, which means these 2 are false. So then we look at door 2. It says the line is behind this door, but that's not telling the truth. So the line is not behind these 2 doors. It's on door 1, it says the line is not behind this door, but they're lying about that, so the line is behind that door. Therefore, the answer is door 1, A. Problem 15. 2 girls Eva and Olga, and 3 boys, Adam, Isaac, and Uriben, are playing with a ball. When a girl has a ball, she can either throw it to another girl or a boy. If a boy has the ball, he throws it to another boy, but never to the boy whom he just received it. Eva starts by throwing the ball at Adam. Who will do the 5th throw? A. Adam, B. Eva, C. Isaac, D. Olga, or E. Uriben. Now, since it says once a boy gets it, the boy can only pass to a boy, we know that Eva and Olga will never get to touch the ball again for this round, so we can already take out B and D, which leaves us with A, C, and E. Then we know that Adam has it, and he can either throw to Isaac or Uriben. And once either of them gets it, they can only throw to the other person, which means that no matter what, they'll always have to pass it back eventually to Adam. Therefore, the answer is A, Adam. Problem 16. Emily wants to enter a number into each cell of the triangular table. The sum of each of the numbers in any 2 cells with a common edge must be the same. She has already entered 2 numbers. What is the sum of all the numbers in the table? A, 18, B, 20, C, 21, D, 22, or E, impossible to determine. Well, we see that they've already filled out the 2 and the 3 for us, so we have to go with what they said, and we have to use only 2s and 3s. So we entered a 3 here, which means we have to enter a 2 here, and a 2 here, which makes a 3 here, a 2 here, 2 here, and a 2 here. And then we look at these. This is 5, 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 and this is 5. So then we add these all up. 2, 4, 6, 8, 10, 12. 12 plus 1, 2, 3, 9. 12 plus 9, which equals 21. Therefore, the answer is C, 21. Problem 17. On Monday, Alexandra emails a picture to 5 friends. For several days, everybody who receives the picture emails it the next day to 2 friends who haven't received the picture yet. On which day does the number of people who have received the picture become greater than 100? So let us write this out. Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So Monday, it goes from 1 to 5. Then it goes 5 times 2. And then on Wednesday, you have 10 times 2. And then Thursday, you have 20 times 2. And on Friday, you have 40 times 2. And then we look at this, because 40 times 2 is 80. And obviously, most of this will probably add up to over 100. So we add these. There's 1 plus 5 plus 10 plus 20 plus 40 plus 80. And we see that on Friday, the total amount exceeds 100. Therefore, the answer is C, Friday. Problem 18. The faces of a cube are painted black, white, or gray, so that the opposite faces are of different color. Which of the following is not a possible net for this cube? A, B, C, D, or E? So we look at A, and we immediately see that these are different, and these are different. So A cannot be the answer. We look at B, these are different, these are different, these are different, cannot be B. C, these are different, these are different, and these are different, cannot be C. D, these are different, these are different, and these are different, so it cannot be D. So we look at E. E, these are different, but these two aren't different. So, therefore, the answer is E. Problem 19. John does a calculation using 4 digits represented in the addition by A, B, C, and D. Which digit is represented by B? So we can see that you add AC and CA, and we know that we would get the same thing. But the thing is, it's not possible to get 2, 2, 2, 2, so we're looking at 1, 1, 1, 1. So in this case, we could have 5, 6, and then 6, 5. But then what would B be? Then B would have to be 0 or A, because if B was 0, then you would be able to have 11 and then 11. Therefore, the answer is A, 0. Problem 20. 4 ladybugs sit in different cells on a 4x4 grid. One of them is sleeping and does not move. Each time you whistle, the other 3 ladybugs move into a free neighboring cell. They can move up, down, right, or left, but they are not allowed to go back to the cell they just came from. Which of the following images might show the result after the 4th whistle? Well, we first have to identify which one is sleeping. So we look at all these 4, and we realize that this one stays stationary, so we know this one is sleeping. Then we look at these. Which one shows that this one isn't sleeping? E. So E cannot be our answer. We move on to D. D, you cannot move diagonally, and also you can't move. In order to move this one up, you move this one up. You can move this one to the side, but then you need to jump this one all the way over here, which does not happen. So D is not the answer either. C. C cannot be the answer because you cannot go diagonally up here. So you could go here, you can go here, but you cannot jump diagonally. So C is not the answer. B seems to be a reasonable answer until you realize that they're not allowed to go back to the cell they just came from, and B violates that rule because this dot goes back down to the cell it was in before. So B is not the answer. So we only have A left. Let us check A. A fits because you can move this one up, this one to the side, and this one up, and then you create A. Therefore, the answer is A. Problem 21. From the following numbers, 3, 5, 2, 6, 1, 4, and 7, Monster chose 3 numbers with the sum of 8. From the same list, Dasher chose 3 numbers with the sum of 7. How many of the numbers chosen by both girls are the same? So we need to get 8 and 7 using 3 numbers each. So in order to get 8, one of the possible ways is 4, 3, 1. For 7, we can do 4, 1, 2. And we can see that they share 2 in that case. Well, then we look at a different version. 4, 1, 2. And then we have 5, 2, 1. We look at this version. This one also has 2. So we can assume that C is the answer because C is 2. Problem 22. 5 balls, A, B, C, D, and E, weigh 30 grams, 50 grams, 50 grams, 50 grams, and 80 grams each. Not necessarily in that order. Which ball weighs 30 grams? Well, we have to look at this one first because this one's balanced out. And so we know that this one is 30, 50, and 50, and this one is 50 and 80. Then, once we know that, we move on to this one. This one has EB, and we see that it's just missing the C. So why not add the C? We add the C to this side, so we have to add it to this side too. And theoretically, it would have to stay like that. But we know that A is either 50 or 80. And so C cannot be either 50 or 80 because then that would make the scale tilt this way, so we know that C is the one that has to be 30. So C is the answer. Number 23. A, B, and C represent different digits. The greatest possible 6-digit number that uses digit A 3 times, digit B 2 times, and digit C just once will never be written in the form. So we have A, B, C, D, and E. So we look at all these possibilities. A, B, C, and E are all the same because they all have all the numbers staying together and not being separated like D has with C separating B. So let's see why D is wrong. We look at D. We get for the last 3 digits, it's BCB. But there are other ways we can write it. CBB or BBC. And one of these two will be larger than this one. That's why D is the answer. Problem 24. The sum of the ages of Kate and her mother is 36. And the sums of the ages of her mother and her granny is 81. How old was her granny when Kate was born? Well, we can substitute variables into here, and we can say Kate is K. So we have K plus M equals 36. Then we have M plus G for granny equals 81. And then we can use the elimination method for systems of equations. And then we have to multiply by negative 1 over here. We get negative K minus M equals negative 36. These two cancel out. You have G minus K equals 45. And then they're asking how old was her granny when Kate was born. So when Kate was born, Kate was 0 years old. Therefore, it's G minus 0 equals 45, which means G equals 45. So the answer to this problem is C, 45. Problem 25. Nick wants to arrange the numbers 2, 3, 4, 5, 6, 7, 8, 9, and 10 into several groups so that the sum of the numbers in each group is the same. What is the largest number of groups he can make? So if we add all these up, we get 54. And then 54, the factors of 54 are 1 times 54, 2 times 27, 3 times 18, or 6 times 9. Now, 2, 3, and 6 all appear, so we can assume that this is not one of the greatest. Now, we have these 3. 2. Groups of 2 would work because you would have 8, 9, and 10, and then 2, 3, 4, 5, 6, 7, and 7 as your 2 groups. And 3 would work because you could have 10, 8, 10 and 8, and then 9, 7, 2, and then 3, 4, 5, and 6. 6 would not work because 10 cannot go into 6. 10 cannot go, 9 would not, because 10 cannot go into 9, therefore 6 is not it, and 2 is not the largest, so our answer would be 3, B. Problem 26. Peter cut a longboard that was 8 centimeters wide into 9 pieces. One piece was a square and the rest were rectangles. Then he put all the pieces together as shown in the picture. How long was the board? Well, this is the square and these are the rest of the rectangles. And we can just split all these into squares by following these lines. And we keep making more and more squares until we've made everything into squares. And then after that, we count the squares. So now you can see all of them are squares. And if we count them, you get 25. But we're looking for the length of the board. And we already know the width is 8. So this is 8, 8, which means 25 times 8 equals 200. Therefore, the answer is D, 200. Problem 27. Write 0 or 1 in each cell of the 5 by 5 table so that each 2 by 2 square of the 5 by 5 table contains exactly 3 equal numbers. What is the largest possible sum of all the numbers in the table? Well, we look at this and we immediately know that for every single one, we have to have 1, 1, 1, 0. So we start off 1, 1, 1, 0. 1, 1. 0, 1, 1, 1. 1, 1, 1, 0. 1, 1, 0, 1, 1, 1. And then 1, 1, 1, 1, 1. Then we count these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 21. 21 is the total sum of all these numbers. So the answer would be B, 21. Problem 28. 14 people are seated at a round table. Each person is either a liar or tells the truth. Everybody says, both of my neighbors are liars. What is the maximum number of liars at this table? Well, we'll say that this person is telling the truth, which means these two are liars. And if these are liars, the thing with the liars is, if they say both of my neighbors are liars, that just means one of them is telling the truth. The other one could be a liar. So we have to take that into account. So these can be liars. And then this also makes sense. But then we need a truth here. And then we continue with that pattern. Liar, 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 liar. Truth, truth, and then liar. So then we count how many liars we have. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 liars, which means the answer is C, 9. Problem 29. There are 8 domino tiles on the table. 1/2 of one tile is covered. The 8 tiles can be arranged into a 4 by 4 square so that the number of dots in each row and column is the same. How many dots are in the covered part? So we have to add all these up and then divide them by 4 because you have a 4 by 4 square. And you need every row and column to be the same. So we start adding them. 4 plus 4, which is these two, plus 6 plus 6, these two, plus 5 plus 5, these two, and plus 3 plus 4 plus x. And then you add all of these and we get 37. And the closest number divisible by 4, the closest number to 37 divisible by 4 is 40. So we have 40 and we know that the only way we can get 40 is if x equals 3. Therefore, the answer is C, 3. Problem 30. Write the numbers 3, 4, 5, 6, 7, 8, and 9 in the 7 circles to obtain equal sums along each of the 3 straight lines. What is the sum of all the possible numbers that can be placed in the circle marked with the question mark? Well, we know that these 7 numbers are consecutive numbers, so it is safe. So we know that the only numbers that can go in the middle is the first number, the last number, and the middle number. Therefore, we realize that 3, 6, and 9 are the first number, the middle number, and the last number. So we add 3 plus 6 plus 9, and we get 18. So the answer is E, 18.
Don't forget to subscribe and like. If you have any questions, you can email info@agoramathcircle.org or comment below and we'll reply back. Maybe. And if you want to see practice things or anything about us, you can visit our website, which is basically the end of the email, but without the info and the end. So bye!